Okay, we're going to continue on our class, solar power tower plant. So here we have heliostat. Heliostat is a solar power plant using a large array of mirrors called heliostats that track the sun and reflect the solar radiation into a receiver mounted on top of a tower. So this you can see like the little square here is all actually a mirrors. All these mirrors, okay, will capture the sunlight and will reflect it back to this tower. You can see here. So the tower will capture all the reflected sunlight and then will harvest the electricity. So the operation, okay, is the water is heated. So water is heated, okay. So all the sunlights all gathered at this tower, and then the water is heated, boiled, and superheated by absorbing the heat from the receiver. So the water here, okay, will get heated, boiled, and superheat through the heat, okay, that receive at the tower here from all the collect mirrors, okay. So this resulting a steam. So a steam, okay, will generate the turbine to produce the power. So that's how you actually get the electricity from the generator that connected to the turbine. So energy storage is also used in the solar project. And in all solar project we use energy storage. Okay, so the cost for this one solar project approximately is about $14,000 per kilowatt. So roughly is about 50,000 ringgit per kilowatt. So which is about 5 to 10 times greater than the cost of electric power station that runs by the fossil fuels or the coal other than renewables. So in conclusion, it's actually expensive to use the renewable energies, but in the long run, it's more sustainable compared to the fossil fuels. Okay, so one example that we want to look in this is Ivanpah Solar Power Plant. So Ivanpah is located in the US. So it started commercialized operation in 2013. So after 3 years of construction period. So it consists of 3 separate units, and the electricity generated can serve around 140,000 homes during the peak hours of the day. So the peak hours of the day is normally from 9 until 5 p.m. in the day. So this is a very large solar power plant. The location is in Mojave Desert in California. So it's the largest solar thermal power plant in the world with a capacity of 377 megawatt. Okay, the current in Malaysia, among the largest solar plant in Malaysia is only about 60 megawatt. So you can imagine this capacity is so much larger compared to our Malaysian solar farm. So this, located at an area of 3,500 acres. That's very big area. So with 300,000 mirrors reflecting the solar energy to the tower, to the 3 towers. They have 3 towers for 3 plants, and the tower is about 140-meter height. And as I explained in the previous slide, the operation, so the tower will capture the solar energy and then will hit the water flowing through the pipes, and then the water will be evaporated in the vapor, the steam. So that will direct the steam turbine located at the bottom of the tower. So this will generate the electricity through the generator. Okay, and we have the condenser to cool the heated water used as well, okay, for this plant. And you can see here is the picture of the 300,000 of the mirrors, okay, located around the tower. So you can see in the picture here, 3 plants with 3 towers. Okay, all right. So here more the close up of the Ivanpah solar system. Okay, where we have the turbine, we have the heliostat. Heliostat is the mirrors. Okay, then we have the receiver, boiler, and also we have the condenser to cool off the water. Okay, and next is the solar pond, a promising method of power generation involve collecting and storing solar energy in a large artificial lakes a few meter deep called solar ponds. Okay, solar energy is absorbed by all parts of the pond and the water temperature rise everywhere. So at the top part of the pond, however, loses to the atmosphere much of the heat it absorbs as a result of temperature drops. So this cool water serves as insulation for the bottom part of the pond and helps trap the energy there. So the salt is normally replanted at the bottom of the pond to prevent the rise of this hot water to the top. So power plant that use an organic fluid such alcohol as the working fluid can be operated between the top and bottom portion of the pond. Okay, let's look at the configuration of the operation of a solar pond power plant. So here you have a pond. Okay, then you have a layer of a salt at the bottom. Okay, all right. So here what happens is the cool water will go through the pump. Okay, and the boiler, the solar pond will go through the boiler, right? And then the boiler will heat up the water and then will generate the turbine. Okay, and then the heated water again will be cooled off. Okay, and condensed back to the pump. Okay, so the efficiency, okay, the maximum thermal efficiency can be determined by this formula. 1 minus the ratio of the upper temperature of the lake and also the lower bottom temperature of the lake. So you see here, if we have 35-degree the water temperature near the surface and 75-degree water temperature for the bottom, so you will see that the efficiency of the thermal is around 11.5%. But if you have the big difference, for example, the upper temperature near the surface is 35, but the bottom you have about 200, for example, then you can increase up the efficiency to almost 80 to 90%. Okay. And passive solar application. Passive solar, the use of solar energy by means of emerging design without the involvement of mechanical equipment, is called passive use of solar energy. Significant energy saving can be accomplished if a house is designed and built to receive maximum solar heat in winter. Okay, to reduce heating energy consumption, minimum solar heat gain in summer to reduce cooling energy consumption. So this may include correct selection of orientation of walls and windows, size and types of windows, wall material, surface color, and finishing of wall surface. Particular preference in design and construction of building will be different in winter-dominated and summer-dominated climates. The solar heating of swimming pool, food drying, and solar cookers are some other example of passive solar application. So here are just the list of the passive solar application for your reference. So for example, okay, here is the throne wall. Okay, so this basically the example of a house for a colder climate countries. Okay, for example, you can see that how is actually the wall trap the heat. Okay, so the throne wall, dark painted thick masonry walls, they are commonly used on the south side of passive solar homes to absorb solar energy and store it during the day and release it to the house during the night. So this is a very good way, okay, to trap the heat from the sun, and then night when it's cold, the wall will release it. Okay, so air vents are commonly installed at the bottom, okay, at the bottom here and at the top of the wall so that the room air enters and parallel flow channel between the throne wall and the glazing. So rises is heated and enter the room through the top vent. So the suitable climate for this is, of course, for my winter climate. So during the winter, it's really helpful to have this solar energy. Okay, this is very beneficial. Okay, so it's suitable where? Of course, it's suitable at the climate wintry. I mean wintry. I mean place. Okay, all right.